By 2050, the global population is expected to exceed 9 billion, thus increasing the rates of environmental degradation and resource depletion that pose a serious threat to human life. In order to counter it, tackling deforestation is one of the main goals to help the net zero emission goals set by Indonesia.
And because of this, over the last few decades, more and more attention is focused in increasing implementation of remote sensing technologies in forestry to handle deforestation, such as Lanasa. However, one of the biggest obstacles when it comes to the application of remote sensing in forestry is the lack of timely data collections.
With this in mind, how can we help in the efforts of tackling deforestation without the drawbacks of standard remote sensing measures?
Assalamualaikum warahmatullahi wabarakatuh. We are ISPO team from Manpat Jakarta, and I'm Muhammad Fazil, Ihsan Lanasa.
And I'm Rafi, Aulia.
And today, we're going to show you our research that is titled Modified Drone Integrated with Object Detection-Based Machine Learning for Enhanced Mobile Deforestation Analysis.
Our research explores the potential use of advanced technologies such as drone imaging and machine learning as cost-effective, real-time solutions to monitor deforestation activities in all forest areas.
All the while aiming to find out the process of making, fielding, and analyzing the performance of the drone that's modified by machine learning-based object detection in monitoring land deforestation, such that it optimally utilizes these experimental solutions in real time while still being cost-effective and efficient.
We have identified two problems that we try to remedy in this research. The first one being, what is the potential for using this research as a way to support Indonesia's net zero emissions goal? And the second one being, can this research be the basis for a more innovative and efficient domestically made deforestation monitoring system? According to Kardash, in 2016, drones or unmanned aerial systems is a capable aircraft flying without a pilot and passenger on board. Drone control is carried remotely via radio waves or autonomously with a predetermined route.
The most important feature of drones is that they do not require any additional infrastructure, which speeds up data collection and monitoring of defined areas or objects. Moreover, it significantly improves the advantage of the very short reaction times when carrying out missions and preparing units for flight. This is the main reason why we try to enhance the drones with machine learning.
Machine learning emerged as big data technology and high-performance computing developed to create new opportunities to uncover, measure, and understand data-intensive processes in operational environments.
In principle, machine learning methodology involves a learning process with the goal of learning from experience to perform a task. For this research, that said task is the application of machine learning monitoring deforestation to object detection. Visual object detection aims to find objects of a particular target class in a given image and assign an appropriate class label to each object instance. This research is conducted in the Manfor Jakarta Physics Laboratory and Mekarsari Field in Kisau, starting from December 2023 until February 2024.
The data collected is based on measuring technical aspects of the prototype that has been created. The primary data being data obtained through object detection results obtained from the drone, while the secondary data is data obtained other than the research subject.
The collected data will be visualized, analyzed quantitatively, and compared with existing data, and further developed based on previous data evaluation. Onwards to the procedure of this research. This research is divided into 4 phases that consist of the planning, prototyping, testing, and evaluating phases. The first phase of this research is the planning phase, where we determine the components that are going to be used, the general goals of the research, and the overview of the research in its entirety.
For this, we use the configuration of the transmitter centered around the Husky lens, and also we use this LoRa transmitter connected to the ESP as the receiver. And as you can see, the husky lens, when it detects a person, it shows a block around the object, and then it can send a packet.
For the drone itself, we use a Sonic model Skyhunter chassis with a configuration that is centered around its powerful 950 kilovolt engine, which is 1.8 meter wingspan. And by this, we can maximize the capability of the range of the drone, so it can further develop its machine learning potential in deforestation. In the testing phase, we are going to test the capabilities of unmodified drones in terms of monitoring by using the Makassar field area as the sample of our research. Okay, take off in 3, 2, 1. In the last phase, we analyzed the data we gathered, and from the results obtained, it can be seen that the performance of the drone is optimal with a monitoring area of 26.27 hectares and a flight time of 6.45 minutes on this recorded flight path. Moreover, the machine learning that was set can determine several points of interest in the area and classify them based on the IDs that appear most frequently with a larger width. Therefore, the use of a drone platform that collaborates with machine learning can be used as an effective deforestation monitoring platform. From the research that has been conducted, we can conclude that the usage of a drone platform in collaboration with machine learning can be used as an effective deforestation monitoring platform in real time.
Furthermore, we hope that this research can be the basis for a more innovative and efficient domestically made deforestation monitoring system that can save Indonesia's forests.
That is all from us. Last but not least, this is Man for Jakarta Drone Team taking off.